we'll just switch places here in a second. So this is lecture 2, week 1, and we will get into the chapter shortly, but I want to just take a moment to introduce a colleague of mine, Brian Jackson. He and I have been working together for a couple of years, actually in the private sector on renewables in a variety of fields that we can get into later. But my main motivation here for introducing Brian is that he's a veteran of the renewable energy technology field. As I mentioned, he worked in Idaho with their Public Service Commission for a while, and also has been an independent contractor on some big wind projects. So he knows solar, he knows wind, he also knows the financing behind it. So when we get later, we did a lot of that already, pricing in 101, and then as I mentioned last week, or on Tuesday, the final chapter of this book is called Integration. And so we're going to cover all the renewable energy technologies, and then when we get to the final chapter, we'll say, okay, how do we integrate things? And it's a good segue because Brian and I just started a company we call Integration Energy, and we're realizing that there are a lot of other people sort of moving into this field. Because last week we said, what's the best renewable energy technology? Well, depends where you are, when it's there. So with that, I'll have Brian come take the podium so he can talk into the mic. But if you guys want to fire off an initial question for him, that'd be great. Otherwise, I just kind of want to hear about Idaho Power. I want to hear about the Alaska wind project, and then I also wanted to have these guys figure out what a certified energy manager is.
Okay.
So those are kind of the 3 topics.
Okay. Yeah, so my background, I got mechanical engineering at University of Idaho and graduated in 1990. And most of my friends were interviewing. You get the job. It's like, there's the big companies that come and interview on campus, and you start looking for those jobs. But those jobs were going to put me in Houston, Seattle, very key market segments. And I spent a life growing up. My stepdad worked for MK, and so we traveled around to projects, mining projects, and he helped build the metro in Washington D.C. All these different things. We coal mines in Wyoming and in Montana, and our whole life was spent trying to get back to Boise. And so my wife and I, we were married when we went to school. She got a degree in biology, and we just said we're gonna go to our location. I guess this is more almost counseling versus the side of things. But we said we're gonna pick where we want to live and find the job there. And the only reason I bring that up is because that it's the thing that made all the difference. There's things that make all the difference in your lives as you go through these different events. Well, so I ended up getting Boise. I'm looking for a job, and there was this opportunity at Idaho Power for a civil engineering job, and I barely even know much about engineering at this point. I'm just out of school. You're fresh with all the numbers. You take the EIT, and you're just sharp as a tack, but you don't know how to do anything. And so when I found this job, interviewed for it and got hired as they called it the lead civil, which is like 3 levels down, but it was like an introduction engineering job, basically helping to manage the contracts and contractors on building a $70 million hydro plant. And so I was working under a professional engineer that was just absolutely incredible, probably one of the best engineers I've ever known in my life. And there's different ways of being an engineer, but if you look at these different things, during that era, I got to be civil engineer on that hydro project. Then we built another one that's like these smaller hydro projects. They aren't big ones these days, but in the 90s. And the next hydro project was a smaller one that was even smaller than that one, and it was an upgrade to an existing hydro plant. And I got to be the mechanical engineer on that. So it's almost like I was building my Leatherman tool, And so I got to do all these different roles. And then the short segue into that is, I started, because I was building construction projects, there was a finite time in my employment. It's like it's going to end in 3 years when we finish the project. Maybe it goes another year, maybe not. And so that helped me always be looking at the next thing. So that's another clue. And I started moonlighting in other departments at Idaho Power. So it was almost like you're moonlighting in different pieces of the company. And I started working for strategic planning. And I started working on their solar energy project. So here's where we kind of jump into the big stuff. Hydro is the ultimate renewable. I tell everybody, in the rock, paper, scissors thing, hydro just wins. Nothing beats hydro. It just flows and flows and flows. But then over time, you find that even that's not totally true. Hydro is not benign. You got the fish issues. I grew up in Idaho where my grandfather had an airplane. He used to fly into the backcountry and catch salmon that were so big that you couldn't hold 2 of them. And you know, that era was pretty interesting. So there's effects. So now you go to the next piece of the puzzle. We put in 50 remote solar home systems throughout Idaho, and we found this incredible market segment that was underserved by utilities. You know, the remote houses, the cabins in the woods, the people just off the grid. And so when you're off the grid, and when you call up Idaho Power, or your local utility, whoever it is, you say, look, I just bought a property and I'm going to put a house, and I'm this far from the closest power line. I can see it from my window. And they say, oh, back then it was about $80,000 a mile. Now it's at least a little bit more than that. But so somebody's like 2 miles away, they can see the power line, they bought the land, they want to run, and it's just only a 2-mile line extension. And the utility says, oh, that's $160,000. And they're saying, oh my gosh, I didn't even pay that for the house and the land. And so they'd yell and scream on the phone, you know, you rip off, you know, thing. And so what happened is we started developing this business that was renewable energy, and as a solar home system that was kind of like the village systems that later on we started looking at for Indonesia, except scaled up to, you know, American consumer type scale. So you're putting in a $30,000, $40,000 system for a home, but with Idaho Power, the solar energy people in the valley said, hey, wait a minute, that's exactly what the antitrust rules. Here's the monopoly utility showing up in our world, going to provide these energy systems. You can buy the parts at lower than anybody. You can do it, you know, all these different things. And so the PUC, they complained to the Public Utility Commission and said, you can't sell these systems. You're competing with us. And so Idaho Power was able to lease them to customers and take a monthly payment instead of, but we couldn't legally sell them. So that the PUC said, you're right, you know, these little guys, you're trying to compete, you're trying to stay alive in the world. And at that point we developed this program that was so profound. Idaho Power was really leading the nation in involvement in renewable energy at that point in time. This is the early 90s. So it was the funnest place to be with somebody who was passionate about renewable energy. I got to work on solar projects. I ended up installing this 18 kilowatt rooftop mounted photovoltaic system on the rooftop of Idaho Power's building. That was my first, you know, all your own project. And I dialed in all of these pieces, and I had the experts coming in from Boston, and we got it all ready. And on the weekend, all the equipment's there. I got the pre-wiring done, and just really nailed this thing to the point where we had a helicopter. In order to get them on the rooftop, we have 90 4-foot by 6-foot PV modules from Mobile Solar at that time. The industry was changing. Mobil, the oil company, had a solar manufacturing company over in Massachusetts, and our company actually evaluated buying that. They had invested between $50 and $100 million in that solar manufacturing plant. The number's probably closer to 100, but you know, they didn't want to admit how much they'd actually spent on that business. And in that brief window of 1 year, Idaho Power could have bought that whole plant and the whole manufacturing facility for $2 million. And the reason I bring that up is because there's transitions and changes and opportunities and things happen, and the oil company says, I'm not going to do solar anymore, but I want it to go to someone like a utility that can carry it forward, because it's not a matter, in that case, it's not the $2 million you paid, it's kind of like derelict buildings that are around town. If you have the money to fix this building up, we'll give it to you for 50 grand. But it's going to take you millions of dollars to do it. So it's like in the manufacturing business, if you don't have the money to carry it to the finish line, it doesn't matter what I sell it to you for, because the next phase. So all these different things have been going on in the industry during that time, and we hosted this renewable energy conference in Sun Valley where we brought in utility executives from around the world, and it was this big, glorious party. I mean, it was like a fascinating thing where it wasn't just executives, it was like top-level people, CEOs of companies, the big energy companies in Europe, and this whole thing came together, and we were ushering in this world of distributed generation, I felt like. You know, so back in the 90s, the mid-90s, you could see the benefits of distributed generation. There are huge reports coming out. You know, you're working for a utility. So utilities, you know, your partners in EPRI, you pay $2 million a year to be part of EPRI, and you get their research, and EPRI's doing their research, and then these big reports, and you pay $2,000 for a market report that shows up, and it shows you what's going on in the world of this and that. And we were right on the edge. And then the CEO retired that was really the champion of the renewable energy segment of Idaho Power. And my boss, by that time I left the generation engineering department, ended up working directly for strategic planning, working on really cool stuff. You know, we're going to change the world. And ended up going to Indonesia, going back and forth to Indonesia several times during 95 and 96, working on a renewable energy business for Village Power. And what we were going to do is show up to the villages, and we said, look, in the entire state of Idaho, there's not even 1 million people. In Indonesia, there's 20 million people that don't have electricity. Talk about an interesting market. It's the single largest market in the world because Indonesia is the 4th largest country. So a meaningful percentage of Indonesia is more than the entire country of Brazil, for instance, type of thing. So you say, okay, as an underserved market, and Indonesia at that point had 8% economic growth for 30 years straight. So as an economy, their economy's doing this. We joked that the national bird of Indonesia was the crane because if you looked out from the Hilton Hotel in Jakarta, there were 17, I counted one time, there were 17 multi-story cranes building high-rise buildings, and it was just this economic thing, and you could just sense it and feel it. And then we'd go from the luxury at the Hilton Hotel to Borneo and Pontianak and going into Sulawesi, and I got to travel throughout Sumatra and throughout all these islands, meeting with villagers and talking to communities in late night meetings where you've got a translator and you're preaching renewable energy. It's like, do this, and we're developing this model that was assessing the ability and willingness to pay and the resource. So in Sulawesi, you've got a lot of coastal ranges with hydro opportunity. Solar's everywhere in Indonesia. It's at the equator. You can stand on each side of the equator. There's buildings in each of the islands, and you can be in that equator building. And so all these different things are going on at that time. But here's the thing. The board didn't vote for, all of a sudden we're traveling around the world to start a business in a foreign country, and then we're Idaho. I mean, it's just, the only place that would be tougher is to do that from Montana. It's like, that's the 2 states that, somebody woke up one day and said, oh my gosh, we spent $750,000 developing a business plan, and we're really never going to go there. Who are we kidding? What is an Idaho utility doing, venturing out into this place? And we had to account for it separately. All the money was spent by the stockholders, so the ratepayers couldn't complain, oh my gosh, we're paying for Idaho Power to go to Indonesia. So we had to very carefully account for my salary, all the business expenses, because it was an outside venture for the utility. Well, CEO changes, management changes, and in a matter of a few years, Idaho Power became probably one of the most anti-renewable energy utilities in the nation, as opposed to that era when they were that close to ushering. I mean, we sold we built a binder that says, here's how you do this renewable energy remote business, the solar home projects and all this stuff, and packaged it like a whole business package. And we sold that package for $10,000 for each binder that we sold. We sold them to like Southern California Edison. We sold them to several big utilities around the nation. It's like, how are you guys doing this? What are you doing? How are you reaching out to the consumers? And some people were actually able to get house financing, because you can't get a loan for a house that is off grid very easily. I mean, good luck with that. It's like, so the fact that Idaho Power was providing the energy service actually enabled a couple houses to go ahead and get conventional bank financing, even though it was an off-grid house. The fact that they had a utility bill changed the lending. And so the reason I share these things is there are all these little clues and pieces of the puzzle. And the thing is, in 1994, when I put that system on the rooftop of Idaho Power, it was an incredible example. It was the largest roof-mounted system at that time, 18 kilowatts. But we had to lift it up there with the helicopter. I had to get a parade permit, and on a Sunday afternoon, we lifted all of those modules, 90 modules, up to the rooftop in the crates, and everybody's going, okay, now what? Should we unpack them and do this? And I made one of those very important decisions, career-enabling decisions. I said, no. High five, and the helicopter showed up with one person who was on the ground, who ended up being at the top of the building. I was the guy on the ground, so back to being an engineer and the hats that we wear, I became the ground guy. So I'm the guy hooking the cables on the containers, and this is a $250,000 system, and it's like on the ground, I'm hooking the cables on, your hands free. It's like anything goes wrong, you lose fingers in an instant in that job. So I did all this, got them up there. That day we had 70-mile-an-hour winds go through Boise. It flipped airplanes over at the airport. If we had unpacked anything, it could have killed somebody. And so the reason I say it's like, always be thinking, it's like one step ahead, one step ahead. But here's the beauty of that project from an actual, nailing it down and what renewable energy can do. Granted, there was 2 months of preparation and getting ready, but on Monday morning we unpacked the crates, and I've got the experts here from Massachusetts. They're leaving on a plane on Wednesday afternoon. We were able to unpack the crates, start slipping them in the holders. We had the holders, everything was in crates on the roof. We had to spread out 90 modules, run the power, make all the connections, and by Wednesday afternoon before they left for the plane, we flipped the power switch and put power through the system. That's what renewable energy can do. Try to do that with a coal plant or a natural gas plant, And so from a distributed standpoint, from a, you could have that system dialed in and show up to Louisiana after the event there. You could have a dialed in system that is deployable and movable. At the end of the event, the grid's back on, we're going to move that system to Albuquerque or some other location, wherever you want to take it. And so the things about this distributed model, it's not nearly as static as you think it is. The other system we put in was a $2 million system for the Air Force out in Grasmere at the Air Force Base in southern Idaho. So that was a remote system that, you guys don't understand about Montana, but it's like that southwest corner in Owyhee County in Idaho is inaccessible. I mean, when the blizzards come through, it can take a couple weeks before the roads get cleared to get down there. It's super remote. Well, the Air Force had a military station down there that was part of the training range for the jets and the things. It's basically just a little, who knows what it's doing, right? Nobody tells you what they're really doing, but it's just inside of a compound. But it has this diesel generator. So that thing's burning 90,000 gallons of diesel fuel a year to run that, because it's completely off-grid in an isolated location. But the problem is, when you can't get there for 2 weeks and all of a sudden the system goes down, who knows how many millions of dollars are invested in that system. It could have been a $10 million system inside that, hurricane fence. And when that system goes down because it ran out of diesel fuel, well, what was that worth? So we ended up putting in a system, and we put in a battery bank that was twice the size of this room. Back then, the costs were pretty high, a $2 million system. And put in this array of photovoltaic cells that displaced a huge percentage of that diesel fuel. So now the diesel became the backup, and that became the primary energy system. And that was, mid-90s. And so bottom line is, I left Idaho Power, got my MBA. They helped pay for my MBA. I got that in '99 from Boise State. Left Idaho Power, started my renewable consulting business, Renaissance Engineering and Design. Thing I always wanted to do. So I started doing consulting, working for farmers and ranchers and developers, and worked on wind projects. And I have developed several companies over the years, but I've worked on biomass systems, small wind projects, very small turbines to the big 2 megawatt turbines, designing the system, designing the projects.
I was looking for that picture of you. I couldn't find it.
On the wind turbine? Yeah, this is our greenhouse in Corvallis. So.
I got a good shot of you online. Just kind of
Well, so that was on top of the Clipper wind turbine on the top of Medicine Bow, Wyoming. I've been up on top of those turbines, you clip on and stuff, and I've been on. We installed 18 wind turbines up in Nome, Alaska. Similar system. My radar screen has always been these like anomaly type of projects. We went up to Nome, Alaska, and we were basically working directly with this manufacturer of wind turbines that was a smaller scale, 50 kilowatt turbines that had been in business for about 20 years, but they're always just barely trying to go to the big time. Our goal was actually saying, look, why are you selling, 50 turbines a year? You should be selling, 500 turbines. The catch with all these technologies, especially the smaller wind turbines, if they were selling 2,000 turbines a year, the cost would be half. But they aren't selling 2,000 turbines a year. They're almost like a Rolls-Royce manufacturing. It's like you got the highest paid people from the management team to the engineers that are part of the assembly line just to put those 50 turbines together and get them out the door, and it's like, here you go, and so when you look at wind energy, we're putting in larger scale wind projects at $1,800 to $2,000 a kilowatt, which is $2 million for a basically 18 to 2,000. So we're right at the cost point, pretty close to where solar was at the in that realm. The problem is, as you go to the next smaller turbines, you go to the 400 to 500 kilowatt turbines instead of the 2 megawatt turbines in a big array, the cost easily doubles. It's really $4,000 to $6,000. And then you go to the next size down, you go to the 50 to 150 type of scale, and those things get into $8,000 a kilowatt installed price. So now you're 4 times more expensive than the big conventional wind project.
Give that number in dollars per watt.
Hard to, do 1,800 a kilowatt and divide by so $1.80.
$1.80. Okay.
Yeah. So we were just chasing $1.80 with the large turbines when I kind of got out of the business back in 2010. So I haven't really been working on wind projects since 2010. So you're right at that cost point where, but at $8 a watt for a small system, you put a small system on your home. The payback for that is so long that you start adding an extra zero to numbers that you really weren't interested in before. If I tell you it's a 10-year payback, in today's society, a lot of people don't even know they're going to be in this house for 10 years, let alone you know, and if I say, well, it's really 30 years, oh my gosh, right? What in the world am I doing? So I'm a true believer. I'm willing to pay a premium, but come on, how much am I supposed to pay for what I believe in? Well, as you start shifting gears into these places, you start finding niches. So we go to Nome, Alaska. Well, Nome, Alaska, the cost of energy is 45 cents a kilowatt hour. So all these, it's like Grasmere, it's like the Air Force Base again. You got Nome, in fact, it's so like the Air Force Base is scary. Because Nome, Alaska, the ocean freezes and goes solid by November. I mean, the last barge shows up in September, and then you got to wait till the spring when the thaw happens, because you're up there in the middle of winter, and it's like you see out there, and it looks like the Bitterroot Mountain Range. The ocean, it heaves and swells, and as it freezes, it moves up, and I'm exaggerating because it's really only probably 100-foot cliffs. But when you look at a flat ocean and you see 100-foot cliffs out there, and you couldn't even drive a snowmobile, 20 miles out there, even though the ice is 20 feet thick, it's pretty weird. And so you look at that, and what happens up there is when they run out of diesel fuel, you got an entire community that can't function. And so they end up having to buy their diesel fuel last year and try to make it through winter, and if they run out by spring, there's nothing that can be done except flying it in on an airplane. If you thought diesel fuel was expensive yesterday, you fly it in on an airplane and fill up a tank. And things like that happen up there. And so we went up there and we said, look, at 45 cents a kilowatt hour, this wind project will pay for itself in a really fast time. We worked with the Native Corporation, but we installed these turbines, and we went through the analysis, and we were trying to get the data, and they said, we're hurting right now. We had this huge bill last year. I mean, it's like all of a sudden the extra cost for them to run things, they only got 20 miles of roads. So we were looking at that and saying, okay, there's a situation here. I went up there because I built this hydrogen project. One of my consulting jobs, I designed and built this hydrogen production project, and somebody up there found me and said, we want you to come up and talk at our renewable energy event. So I go up there and I talk to them, and I'm walking around, and it's like 10, 15 degrees outside, and there's like not just kind of wet spots on the street, there are puddles on the street. And I looked at him, and it's like January, and I told him, I said, you need to really look into your solar resource up here, because remember what happens in Alaska is like you have long nights, it's like, so in the middle of winter, the daytime's only 2 hours long, but in the summertime, daytime's, 22 hours long, type of thing. And so I said, you should check into this. Well, they did, and they ended up, between that time and the next year, installed these photovoltaic systems. You put the modules vertically, by the way, because you're Nome, Alaska, you just face out. So they put on the south side of the building, and they're offsetting, because remember, they're offsetting 45 cents a kilowatt hour electricity. It's that's a really interesting game changer, and they're isolated and all these different things. Well, so we ended up installing this system. We ended up basically getting a deposit in March. We went up and made the presentation in March, and we said, if you give us a deposit in the next 10 days, we can order these turbines, design a system. We said, we'd like to put in 12 turbines, and we said we probably could put in 18, and it was one of those presentations where at the end they said, well, why would we put in only 12 if we could do 18? And within a week, all of a sudden there was $1 million transferred, and we made a deposit on the turbines, and we started designing the project before we even had the data on the wind. Now with wind, you have to have like 3 years of data, and they've been collecting data, but the state had been collecting it, and it's out one of those remote anemometers that you go out there, and I've put up dozens of anemometers throughout Idaho and Oregon and throughout the western states, and you're up on a mountaintop, and one time in Duck Valley on the Indian Reservation and the border between Nevada and Idaho, and I've done a lot of native tribal lands put up anemometers. But one time we went to get the chip, and we couldn't get within 2 miles of the site, and I said, hey, I hunt like this all the time. It's like, you just hang here. That'll probably take me a couple hours. I'll run up there, get the chip, and come down. Well, the snow is a lot deeper than it looked, and pretty soon I'm in snow that's, it's over my knees to begin with, but then it's up to my waist, and then it's like 2 hours turned into 4 hours. I couldn't even find the four-wheeler when I came back. It's like 7 hours later, it's like I'm right at dark, and finally found him, and he's looking for me, and I'm looking for him, and so it was one of those kind of things. So here's the anemometer in Nome, Alaska, but nobody'd gotten the chip and this and that, and we finally got the data to the state who was in charge of that, but we finally ended up getting the data, and I was working with the Idaho National Labs. One of my best friends was working there, and so we showed up with all the data, and I had hired this engineer. She's working for me, and we started analyzing the data, and the place where we had intended to put the wind project, we've already put the deposit on the turbines. It's in motion. We're designing stuff. We're pulling the pieces together, and there's not enough wind in the valley. Snow, Alaska, it's brutal. The wind is staggering up there, but in this particular valley, the data doesn't lie. So there's just not enough wind to do a commercial project there. And so I looked at the engineer that I hired, and she's, you know, I mean, we're all speechless in the whole room. You know, nobody even knows how to talk. And I looked at her and I said, you know, as engineers, it's like we're problem solvers. I said, this is one of those things I remember I actually said, you know, I've never seen a truck full of more lemons in my whole life. Our job is to make lemonade, you know. And so, at any rate, we ended up going through some sophisticated analysis and some crazy. You know, there's a lot of software in the wind business where you can take the data from this, put in all of the topo maps and the terrain, and you can actually correlate the data from this location 3 miles away to this location. And it's pretty accurate. It's amazing because it says, well, if the wind was here at this level, now remember the wind, there's a shear. So the wind, you know, it's like if you measure the wind speed in a wind tunnel, at the boundary the wind speed is 0, and then it's free stream at the center. Well, it's really close to free stream within some core of the center, and then it you know, tapers off. So you're doing all these analysis. We basically moved the entire wind project up to Banner Ridge. Well, it turns out Banner Ridge it's way beyond, so it's brutal. So we ended up putting the turbines on a place where the wind was so intense, it just was beating on these things all the time. The other thing that we didn't really factor in is it's Nome, Alaska. The humidity is super high, even though it's like, you know, 10 degrees outside. I mean, we ended up finishing that project by the end of the year. We flipped a switch by the end of the year, which everybody said you can't build a wind project up here in less than 3 years. And we said, look, we got the turbines, we do this, we did this. I bought transformers from another utility and shipped those on the barge, and then bought transformers in the lower 48, shipped those on a barge up to Anchorage to replace the ones that I bought. I mean, I had to find materials from all these places. We had to fly in things like nuts and bolts. We were building this, some days we had to wait till it warmed up to 15 below just to work out there, because it's just really hard to work out that side. We're doing wiring, we're wiring each of these 18 turbines with, you know, screwdrivers in the terminal strips. You know, it's like an 18 connection point where we had pulled the wires, and so we're pulling the wires. The way that we got the wires up there, just to pull the wires, I bought an F-350, you know, like the trucks that I buy here. It's like a crew cab F-350, 4-wheel drive. Bought it in Boise, shipped it up in a shipping container, and loaded up the container with everything from barbecues to fishing poles and nuts and bolts and shocks. And I bought these $30,000 mat tracks that bolt onto the hubs. So we're driving this F-350 that looks like a snowmobile up and down this mountain, 2-mile road up and down the mountain. Built a wire rack that had 16 spools of wire, pulled the wire ourselves through all those conduits from all these turbines. There are 1,000-foot runs were the longest ones. Most of them were about 300 to 500 feet. So we're pulling these spools, and only one of them didn't work right. Well, you're pulling, and out of all those, because we buried them with rocks in August. You know, it's like we're now pulling wires in December. So all these things to get this project done. Got it working, got it running, kept it going for several years. They were really having pressure. And in the end, the manufacturer, even though we sold more turbines that year than they had sold the previous year, just our company, they still ended up going bankrupt. So now you've got warranty repairs on a machine that's, you know, it's like, here we are ushering in the new era, and we went to this brutal location. And here's the other thing about this brutal location. So it's like, did we do them a favor? Well, maybe they broke even. I don't know. You know what I mean? It's like, I don't know. They helped usher in a renewable energy era on a place that's captive to diesel. And I think if you just change people's perceptions sometimes, it at least opens up doors and opportunities. And maybe they broke even. Maybe they lost a little bit. Maybe they made some. But the truth is, all of the infrastructure we built up there, they can replace those turbines with other turbines. There's opportunities there. And I will tell you, the thing is, you know, remember, we're offsetting 45 cents kilowatt hour. Well, so the thing is, the thing's generating at night. It's Nome, Alaska. Well, the grid is pretty small. You know, it's a very small community. So what I kept telling them is, this is the place to usher in electric vehicles. I said, you only have 20 miles of roads. So they were going to build a battery bank like our situation at Grasmere, right? We're going to store all this energy because we can give it back tomorrow in daytime, and it's a very small grid. I mean, that whole system was basically 1850 kilowatt turbines, so we were just over a megawatt. That was the first wind project in Alaska that was over a megawatt. And then the following year they put the turbines on Kodiak Island, the GE machines. So those are a megawatt apiece, so all of a sudden that became the next biggest one. But as you looked at that, and they were going to put this batteries in this room, and I said, man, Their system, every light pole downtown has an outlet on it, so you can plug in your diesel truck because it's 20 below all winter long. So when you stop to have lunch, you plug in your truck, go have lunch, and then come back and start it up. And almost everybody else, most of them, they just leave them running. I mean, some of the places in Alaska, they start the truck in August and they don't shut it off until June. They shut it off to change the oil and hope they can get the oil changed fast enough that the oil doesn't get solid. But that's way north of Nome. Any rate, I said, why would you put these batteries in a room? Why don't you create these? You got the taxis, the utility vehicles, and stuff. Create a little mini mobile microgrid. Every one of these vehicles, they only drive the whole town is you aren't driving more than a mile. If you go 20 miles, you're clear out, and half of those roads don't work all winter long. So why don't you create this mobile battery system that moves around, and you quit burning diesel and gasoline in those vehicles, which is worth a lot. You've got the wind that charges the batteries. They're only unplugged from the grid for a couple minutes at a time just to go across town, and then they get plugged back in. So what I'm trying, the thing I would share with you is there are some really interesting opportunities for these elements, and then we started talking about even hydrogen. It's like if you have this wind power. So what we found with the wind on Banner Ridge is these turbines are rated 50 kilowatts. The main failure mode was overgeneration. These things, the air was so dense. This is what we wouldn't have had. I mean, it's like this part of the equation had never been really figured out before in the case that, so these things were generating 90 kilowatts. The air was so dense that even with this small blade, you have a phenomenal wind, right? So it's just incredible velocity and steady state. But the density was the thing. So air, remember with renewable energy and kinetic energy, it's velocity squared. So if you're running your car at 150 miles an hour instead of 75, it's 4 times the energy, 4 times the stopping distance, 4 times the braking power. One of my professors said typically 4 times the wear and tear on your machine to do that. So you people that are zipping around all over the place, good luck with that. But with wind energy, it's velocity cubed. So if you double the speed, it's 8 times the energy. So when you look at these wind turbines and say, oh my gosh, they all shut down at 55 miles an hour, and some of the bigger blade turbines shut down at 45 miles an hour, it's because when you move that wind speed up incrementally, the energy becomes phenomenal. So if you say, okay, and so what happens though is you go to assess the wind resource at sites, and you start assessing the wind, and what we find with wind, some people say, oh my gosh, wind is so unreliable. It's important for us to start working on our lexicon and the way that we discuss and talk about things. What I tell people, a lot of presentations, I said, if wind was unreliable, we wouldn't have discovered the New World. Everybody who left, Europe on a sailing vessel, because all we had was sailing for centuries, for millennia. Sailing was the mode of power, and it was reliable mode of power. You knew that you left, and as long as you didn't fall off the edge of the earth or get eaten by a dragon or a sea monster, the wind would take you to the South Seas, and it would bring you back from the South Seas within some pretty good parameter of time. They didn't sail to the South Seas and say, I hope to see you in the next decade. It's like, I can go there and I can come back in this year and I can harvest this and bring this and do that. And then we look at what we did across this nation. Well, and look at Europe with the grinding mills. You were grinding the flour and grinding the stuff. Well, what we find with wind over an annual basis on a lot of wind sites with multiple years of data, and you're taking 10-minute interval data. So every 10 minutes I'm doing a click, 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 every 10 minutes, and assessing what the temperature, humidity, if I'm really, especially humidity now that I care about that more than ever before. In Montana, the humidity stays within a range that doesn't change it that drastically. But if you look at wind sites, commercial wind sites, they vary typically plus or minus like 5% on an annual basis. So the actual amount of energy that this wind site is going to generate year after year after year for the next 20 years, the life of the contract of this renewable power agreement, selling to the utility under a contract, over the annual period, it might be plus or minus 5%. Well, hydro, we see hydro is plus or minus 40%. Remember I said rock, paper, scissors? Well, you have a drought year, it's like, oh my gosh, hydropower is 40% down. Hydropower has 17 hydro plants. At one point they were as much as 80% hydroelectric energy, and then as the loads grow and you don't build another hydro plant, you're a little bit less, but you're still almost 50% hydro. Well, on a bad year, you only get 40% of the energy from that hydro plant that you were going to get. On a good year, oh my gosh, you got 150%. So look at the variableness of hydro. On the other hand, I'm getting that energy from a plant that was built 80 years ago in some cases. You know, so I've got an embedded cost that's so historically, I've paid for that thing so many times over, and then after 50 years your license expires with FERC, so you get a 50-year license. After that 50 years you apply and renew your license. So the same hydro plant that I built in the 90s, we built that for a 50-year lifetime, knowing that at 50 years it'll get renewed and go for another 50 years. So that's an asset that just keeps going and going and going. So you look at the renewable aspect, you know, that's you know, heavy infrastructure. But I guess what I just kind of wrap things up and say, you know, it's like, and I can kind of touch the certified energy engineer. So the last thing I did with Idaho Power is I went through the classes and spent the training and got the CEM. So I got my PE license working for Idaho Power. You know, you take the PE exam as fast as you can if you're an EIT, especially in a company like that. And then I got the certified energy manager. And for the last 2 years of my life with Idaho Power, we worked on a subsidiary company. We were working on products and services for commercial and industrial clients. So we were traveling around the western United States trying to sell products and services outside. Again, this was a lot of my stuff was outside of the Idaho Power, the utility company. It was in these other ventures. So we were going to places like Callaway Golf. You assess their energy loads, their manufacturing place. It's like the Willy Wonka's, you know, candy factory. I mean, they check everything in your pockets, and you know, it's like no secret sauce is leaving this factory. But you looked at their energy loads and how they can you know, save energy on their loads, how they can do that, and what they were doing was creating backup solutions, because their factory, the grid was really hot in 2000, where a lot of outages in California, especially when it gets hot, which, you know, a new part of this new future is your reliability factor. So one of the big reasons for renewable energy is, hey, if the grid goes down, and I've got, what they had is the core of the Callaway golf ball is a super special recipe, and it's like a big taffy machine. And so you have this big taffy machine the size of this room, and it's up elevated and stuff, and if the grid goes down, that thing quits moving. Well, now you've got golf ball taffy inside of a machine that you've got minutes, probably a little bit more than seconds, but once this stuff goes solid, you're in there with chisels. They've had to do that a few times during the manufacturing process, and it's a whole room of chisels off of the blades and the knives and the parts and the pieces. And it's like, because you can never make it turn again. You know, it's like the entire room is a golf ball. And so here's this, you know, complex taffy machine. Well, so you look at that and you say, well, what's it worth to them to have a backup solution for power? A fortune. Well, what's it worth to them to install energy systems that there's stability of delivery, and then there's stability of supply, and there's stability of rates. Renewables tend to cross all of those boundaries for people. So you say, look, if the grid goes down and I can't get power for any price, what was it worth for me to stay in business? Well, if you've got livestock and you're on a farm and your pumps are based on that, or you're irrigating crops and the sun's shining and the grid goes down, you might have hours, you might have days. You know, what's your reserve tank? Well, you start looking and you say, man, I want a reserve tank up on a hill. You know, we've got this 80-acre ranch in Stevensville we're working on, and we're saying, okay, we should have a water tank on top of the hill that we fill. I can put a renewable energy pump down there that pumps just a little bit of water on a steady state. Every time the sun shines, it just keeps putting water up there. Or I can put in a renewable energy system that'll run all the sprinklers in the property. Well, the thing that fills the tank is going to be a fraction, a tenth of the cost. It can never run any of my sprinklers, but it can keep the tank full depending on the usage, right? So you start assessing the resource and you say, okay, if on the other hand you want a system that'll run all the sprinklers, now you have to put in this huge amount of capacity. So you get artistic with assessing the resource and matching it. And so the certified energy manager training really is how do you assess the loads, the thermal loads. You know, you got the sun coming in, air conditioning loads. You know, when you start looking at all of these different pieces of the puzzle, when you start changing, one of the big things that hit a lot of buildings, when you start switching to LED lights, LED lights are super efficient at producing light, and they don't produce the fascinating amount of heat. Remember, light bulbs were typically, it's like 30% of the energy goes into the illumination, and 70%, you know, goes into heat. Well, so guess what? That means in the wintertime, that 70% heat is heating the building. So your HVAC system to heat the building never had to be nearly as big as you thought. But the AC load in the summer was phenomenal. So a lot of our energy systems in the buildings around the nation have been built on that model. It's like, oh my gosh, I got to have massive cooling to deal with this lighting thermal load, and then top off the windows and things. It's like just putting the 4-foot overhang. So match up with the architects. The 4-foot shading overhang, all of a sudden you can drop the energy, the cooling needs of the building by 30% just by shading a little bit, and instead of letting the sun shine in the windows. Well, so we're in this era now where things are changing. So when you start saying I can change all of these lighting loads, change the thermal loads, change the energy use for the building, all of a sudden now some of the renewable energy technologies like photovoltaics on the rooftop might be able to run the building. And if you look at like what we're working on, this biomass energy technologies, you go to Darby, the little micro things. Part of what brought me to Montana in the first place was going to the Darby School, looking at the Fuels for Schools program. So they've got the this biomass. They're burning wood chips in their boiler. That saves them about $150,000 a year compared to conventional power needs. So there are always examples of very cost-effective solutions, and what we need to do is look for those examples and magnify and multiply those applications, as opposed to putting a wind farm in Nome, Alaska, even if it has phenomenal maintenance issues and phenomenal struggles and stuff, it's offsetting an incredible burden for supply and delivery and cost. So you say, okay, well, in that case, the cost-benefit ratio is completely different than if I did the same thing, here. So you say, where do these things fit and why? And I think that's this next era that we're going to see is the prices have come down so many times in so many places to a place where the overlap in those overlaps are showing up all over the place.
Thanks. The questions are all there.
Yeah, any questions?
What do you see as the biggest hurdle to ushering in that era of renewable energy being the primary source for our country? I'm sure there are many all over, in every state it's probably different, but like generally speaking, I'm assuming it's policy.
Yeah, well, it's resource constraints. So just at the point where you think everything's going to change and oh my goodness, it's like the world is going to change from the renewable standpoint. So let's look at where we were in 2000. 2000, the grid goes crazy and lights are going out in companies across the nation, and California especially. Well, the utility has this obligation to keep the lights on for you, almost regardless of what it costs, because their model is to manage costs and control them, but if they can, they have to keep the lights on. Everybody's depending on it. People have breathing machines in hospitals, and it's like there's all kinds of things relying on. The entire economy depends on the utility keeping lights on, and guess what? Our utilities are pretty good at it. As good and bad as you might feel about different things that they do, I don't think there's a utility in the nation that's less than 98% reliable, and usually it's 99 point something. It's like, how many outages did you have last year? Well, in Bitterroot we've had several, but how many that lasted a day? Well, none. Part of a day, I thought it might last a day. I've got greenhouses, so all of a sudden I'm thinking, oh my gosh, I got to fire up my generator. I got to keep them above freezing. I'm out there checking, and one time it was out for 4 hours, and the greenhouse was down to 55, 50, and I'm like, oh, it's like. But you know what? Before I got to the generator, now I'm going to say, oh my gosh, I got to fire up the generator and figure it out because there's a generator there. As I'm screwing around with all that, lights came on. So you're like, okay, phew, dodge that one. Should have gone ahead and fired up the generator, but it was midnight. It's like I'll deal with that later. But it's like so the point is, so cost of natural gas was doing this, right? So we're looking at cost of natural gas. Cost of wind energy is coming down really fast. So right at the crossroads was 2010 when the world changed dramatically. So I had 5 wind projects that I finally had reached the pinnacle of my development career, and I was developing 5 20-megawatt wind projects to build them, and I was 50-50 partners with the landowners instead of using a major developer. So had we been using a major developer, we probably would have had access to $1 million worth of legal assistance to try to fight the battle that we ended up losing. But in the end, we got screwed and we lost everything. Here's what happened though. I'm selling these wind energy projects, and for this limited time, my contract with the utility that I didn't end up getting honored by the PUC, even though Idaho Power signed it and we signed it, and it was a real life contract, different story. The levelized rate from the energy for 20 years from these wind projects was 7.2 cents a kilowatt hour. Next year, when we get the project built, I'm selling it to the utility for 5 cents a kilowatt hour, then it's 5.6, 6.1. You know, it goes up over the 20 years. You know what every year what you're getting paid for the next 20 years when you sign that kind of a PPA with the utility. In year 16, I know exactly how much it's cents per kilowatt hour because that's the contract I signed for. And in year 17, if I don't deliver the power, they're going to sue me and say, you promised to deliver power for 20 years. What the heck went on? I say, oh my gosh, everything broke. So I have to take care of those things because for 20 years they'll own my wind project if I screw up. I mean, I have signed a legal obligation to deliver. When you're selling it, it's different. So at any rate, Idaho Power that same year approved the Langley Gulch natural gas plant in Payette, Idaho, and they built it, got it approved from the PUC, and the levelized rate over, I don't know if that one's a 30-year life, but maybe let's assume they're 20. But so the levelized rate from that project, that natural gas project, which they needed, because it helps juggle everything in the hydro, the wind, and all the things in Idaho. We need this natural gas plant. The levelized rate was 11.7 cents. That same year, Idaho Power took out ad campaigns, anti-wind, anti-this, a big wind turbine and a full-page picture in the paper that was missing a blade. It's like the missing thing that you don't know about wind, you know, and it's like this hype and stuff, and it's like, so you hammer with wind. The thing with wind is, I can't promise you I'll deliver energy next Thursday at noon. Offer me $10 million. I don't know. Is it going to blow next Thursday at noon? I know the spring winds will come. Will they come in February or March? I don't know. You know, roars in like a lion, roars out like a lion, whatever. You know, it's like the spring winds always come. But which day are they going to show up? I don't know. So the utility says, man, I have to always be ready, always serve. I have to always have backup. So their biggest complaint is, I've got to have 100% reserve someplace just in case you never deliver. And the day that you do deliver might be the day that I just didn't even need energy that bad anyways, which may or may not be true. And so it's about diversification and portfolio management. So when you get back to this, so at that point, the gas plant was 50% higher over the life of those two projects. The gas plant was 50% higher than me, and I'm the bad guy trying to rip off the ratepayers. So again, now, but then look what happened within 5 years. Within 5 years, natural gas prices plummeted from $8 to $10 a MMBTU down to $2 per MMBTU. Well, guess what the Idaho Power ratepayers are paying? Look, when they built that project, they had the contract for the next decade. I'm sure that they're still paying a contract that looks like 8, 6, maybe 6 because they're a big buyer. I'll bet you the Idaho ratepayers are paying 3 times for natural gas, the cost based on the contract, because you can't build a $100 million plant and not contract for the fuel. So the ratepayers are paying that 11 cents. Granted, after 5 or 8 years, that contract probably is going to run out, and they'll probably get a new contract for a lower price or something. But as a society, you know, we're missing several pieces of this because the machine wants to keep, you know, things in motion tend to stay in motion. You know, we got momentum. So the machine has a lot of momentum to do the same thing the way it's always been doing them. I think that the biggest takeaway that I try to give you is my life. I've tried to spend a whole life looking for ways to break out of that stagnant momentum. I mean, there's a reason I left the utility company. It's like, you know, you can retire fat, dumb, and happy, you know, and just work there the rest of your life and, you know, pay a lot of bills with a steady income. I chose a way different road. But as you look through that, in order to bring in the renewables, if natural gas is cheap and abundant, is it going to be cheap and abundant forever? Do we build 80 natural gas peaking plants across the nation, which is, you know, what we did, or probably more like several hundred, but all the utilities in the whole nation build these natural gas peaking plants. If all of a sudden there's a constraint on natural gas and it's not as abundant as it was yesterday, everybody's counting on natural gas. So my argument to the utility is, man, while you got an opportunity, you know, before the lights go out, should you have, you know, at least 10% wind? Should you have at least 10% solar? Well, that's 20% that's completely odd and different. It's not fuel related. When you put in, this is the other thing that you preach to people when you talk about renewable energy, biomass projects are fuel related, so you say, what's my resource? What's the mountain? Where's the wood? Where's it coming from? Am I growing fuel crops? Am I growing fuel trees? Am I harvesting the wood waste like we're targeting, you know, that abundant resource? Well, it's still, you know, it's either finite or it's renewable. So the forest is renewable unless we don't manage it, and then it's like dying so fast that we, you know, is that really renewable anymore? I don't know. I mean, you know, could we make it renewable? Yes, the sun comes up. You know, it might not come up tomorrow because of the clouds, but it's going to come up. With the wind, almost all of the renewable energies on the whole planet, well, all of the renewable energies I'm aware of really are driven by the sun. That's why we use fusion in one of our terms. You know, it's like the fusion energy is the ultimate source. You're growing plants, you're growing this, the wind is moving from solar thermal differences across the planet. Solar photovoltaic, you know, you got the efficiencies there. But when you buy that photovoltaic module, you got a 20-year warranty, you put that in place, and there's no fuel. I got cloudy days and sunny days issues, but there's no fuel dependency there, which is, to me, as a ratepayer, as part of society, I really love having, you know, if half of my energy came from sources that were not fuel dependent, that you know, if the truck doesn't show up, if the pipeline, you know, back to in the early days of renewables, back in the 2000s, James Woolsey was a huge advocate in renewable energy, like huge, and he was the former director of the CIA in the 80s, 90s, you know, for that, and it's like, so I always thought it was an interesting clue that the guy that knows more about stuff we'll never know about is like, he was absolutely nuts about distributed generation, saying, man, we are so, but what we get like frogs in the water is like, are you really worried about the vulnerability of the power grid? Well, no, it kind of always stays on. Well, if somebody started attacking a power, you know, now you can't go into utility offices, you can't get maps of the grid. It's like all of that is, you got to sign security. When we started doing wind projects, we're out in the rural, we're assessing wind and how do you get it to the grid and stuff. You got to go through a background check in order to get the utility map. When you go to the natural gas guy was out at our place and assessing part of our lines at the greenhouse, he couldn't even show me the map he's holding on where the gas lines are. It's like, well, I can't show you this, right? Because it's a vulnerability that we never really thought about being vulnerable about. But it's like, if you have photovoltaic modules on your house and something happens to the grid or the power plant, you know, the first thing that happens in countries and wars is you take out their grids. You know, so local distributed grids are really, really safe. You know, so there's a lot of reasons for us to, again, am I going to replace all of that? No, but should I have part of it? Guaranteed.
Yeah.
Sorry.
Hey, that's perfect, Brian. Thanks a lot. Thank you. Okay, guys. So I'll just park the recorder right there. Thanks again, Brian. That was perfect. That was fantastic. And then